Now that we've set up some nice detail and trimming for all of our procedural cutter geometry, let's create an HDA for this to make a reusable tool that we can use to streamline our fracture workflow. So to start, let's just select this entire network that we've built to create these cutters. And if you press Shift-C, that will condense all of this into a subnet. Anytime that you have a network that's getting to be a bit complicated and difficult to look at, you can use subnets to help organize your setups and make them a little bit cleaner. So even if we have no intention of making something into a separate tool, it's often helpful to create these sort of subnets to isolate different parts of your workflow. So here we can just pull these automatically built subnetwork inputs to the side. And I always like creating a null after that first input to view our input geometry. I'll just call this input geo. And one feature that I've found really helpful for this particular setup is allowing us to combine our own input meshes with the procedurally generated ones and have them pick up the same noise settings. So for example, if we jump out of our subnet, let's just create a big sphere. I'll just create a sphere like so, connect it to our input geometry, and that will automatically make a bounding sphere around our building piece. And I'll switch that to be a polygon with much higher frequency. Let's try 20. And then I'll use a transform node to shrink this down a bit. I'll template our original geo so we can see what this looks like. And we'll scale this down a bit. Maybe turn on these transform handles to raise this up so that we can position this cutter exactly where we want it. Cool, that looks good. And then we'll wire this into the second input of our subnet and dive inside here. And we can grab this subnetwork input 2, and we'll bring this over to the other side of the network to keep things clean. Let's grab everything down to that copy to points, raise that up a little bit, and we'll add in a merge node. And similarly to before, we'll create a null for that extra input, call this extra geo, connect input 2 there, and then connect that null to our merge node. Now this extra sphere geometry that we've added is a bit lower resolution than the scattered grids are, and when using this extra secondary geometry, it's best to ensure that the resolution is at least somewhat close to those grids. So let's jump out of that subnet, go to the sphere, maybe triple that to about 60, and you can see that now that resolution is much closer to what we're seeing on the grids. It doesn't have to be exact, as long as it's somewhat close. And if we switch this to smooth shaded mode, you don't see a huge difference in how that noise looks on the sphere as compared to the grids. Now let's dive inside our subnet and add in a few more features. Whenever you're working in a subnet, you always want to make sure to add an output node. Without this output node, then whatever node you have displayed is what will be output from your subnet. So for example, if we put our display on our low frequency noise here, then when we exit our subnet, you'll see that that is what is being used as the output here. And that's pretty dangerous because if you're working on things within your subnet here and you accidentally leave your display flag on the wrong node, then that can really mess up your output. So definitely always drop in this output node so that the end of this chain is the output no matter what your display flag is set to. Before we output this geometry at the very end, I like to add normals to my cutter geometry. You could also optionally add some UVs as well, or any other features that you find to be helpful as you're working on your shot. Sometimes depending on your production workflow, it can be useful to be able to specify different UDIMs for the inside face UVs, because the cut areas of our building asset will pick up the UVs from the geometry we're cutting with, at least for the inside faces of those cuts. And it can be helpful for some shading processes to know which UDIMs the inside faces lie in. But as I said, it's really an optional step, and in this class we're not really worried about providing UV-based textures for the inside faces. We're just going to utilize REST data for applying some procedural bump. Now that our cutter generator is in a pretty good state, we can start setting up the HDA for this. So let's go to our subnet, and we'll give this an intuitive name. I'm calling mine cutter geometry _ Keith Digital. That's my website. You can come up with your own little HDA prefix or suffix for your own tools. And then let's make sure that's selected and go to this little gear icon in the parameter editor here and go to Edit Parameter Interface. You can select these labels that exist there by default. You can make those invisible. And now you can set up any controls that you think you might want at the top level of this tool. We have all of our standard parameter data types here. For example, we can use an integer for the number of cutters. You can specify the name of the parameter here, and then a nicer name for the label. So for the actual parameter name, we might just say num cutters in camel case, which means, lowercase at the beginning and capitals for each word after that. You can't have any spaces in the name there, but for the nice label, you can have spaces here, like so. For each of these parameters, you can specify a range for the sliders and whether you're allowed to enter values beyond the slider range by locking either end of it here. And then under channels, you can put in a default value in here. Like if we want this to default to 10 cutters, we can put a 10 in there. Maybe we want the range to go from 0 through 100. We might want to lock this at 0 on the low end, so you can't put in negative numbers of cutters, but you'll want to unlock that in case you want to enter really large numbers of them. And then you might want to add in an integer seed as well. We could use this seed for, varying up the seed for our scatter, or maybe an additional offset for our noise that we're applying. For padding values, you might want to use a float vector 3, because this will allow you to put in X, Y, and Z values. And the other one that I've found useful for this tool is the toggle, which is just a checkbox for various options, like whether you want to trim based on the object's volume, and if you want to output that cutter ID attribute. Now for any of these parameters that you set up here, you can just right-click on those, copy that parameter, and actually one thing that can make this a bit faster and easier to work with is if you hit this little pin on the parameter view here, so that when you dive inside your cutter generator, you can hit P in your network view so that you can see the parameters for whatever is selected here, while you still have access to all of your main cutter generator parameters up here. So for example, we could right-click num cutters and copy that parameter, and then paste the relative reference into our scatterer here under force total count. And if this parameter here was for our padding on our bound expand, you could copy that, since that's a vector, and you could put that on our bound expand down here. You can see now that lower padding has become 0 to match what we have in here. You can do the same thing for checkboxes. This is essentially a 1 or 0 value. So you can right-click that, copy that parameter, and in this case, you might want to use a switch statement that's linked to that checkbox. So if this checkbox is driving whether we're outputting the cutter ID attribute or not, we could drop in a switch here, drop that after the attribute promote, and then on one hand we can delete that attribute with our attribute delete node, select cutter ID. Of course that's going to be under points because at this point it hasn't been promoted. We'll hook that up to the switch and we'll say delete cutter ID. And on this flip side we'll promote cutter ID if we want to export that. And then once again, if we copy that checkbox parameter, you can paste that relative reference right into the select input option of the switch. So that will be either 0 or 1, depending on how this is set. However, 0 means that we don't want the attribute, so we'll need to hit this little up button to reorganize the order of our switch inputs, so that the 0 coming from the checkbox means we get the delete cutter. And if that's a 1, then we get that cutter promoted to primitives, which will follow through to our output.